Okay, take 582. Hey YouTube, it is good to see you again, and well, I have something that I purchased recently, came in the mail. I'm excited about it because it's going to go in the mill, and so I thought I would share that with you real quick and talk a little bit about roller guides on the mill, just one aspect of them actually. I bought these things from Cook Saw Manufacturing down there in the great state of Alabama, and they actually have a lot of good instructional videos and just general tips and tricks and whatnot on YouTube. And so, hey, I'd gladly say go and watch their videos, because you will learn a lot if you're a sawmiller from watching those videos. And seems like they run a fairly upstanding company. Have no connection with them whatsoever. Just happened to purchase this item, and it's my first item, and it looks pretty decent, I would say. So here are the two roller guides that I received from Cook's Saw Manufacturing. I ordered these, and it took about a week to receive them. They are the 2-inch diameter version, so it's the standard guide, and I didn't order them with anything other than these here. So they come with the non-greasable bearing installed. But there's a snap ring in here, and you can take the bearings out easily and replace them, so I don't consider that a big deal. So like I said, they're the 2-inch, therefore an 1.5-inch blade. At 1.5 inches, if I can tilt that up correctly, the blade is going to stick out just a little bit beyond the roller guide, which is proper because you do not want the teeth of the blade to ride on the roller guide and become flat. You want the teeth to be out in space here. I think these are made fairly well. I didn't check the hardness of them, but they say that they're hardened, so I'll just take their word for it. It seems to be a part that's machined and looks kind of like American machining. Doesn't look like Chinese machining to me. So I'm sure that they made them right there in the shop, as they say. Looks like a very good part, and I would recommend going this route if I had to do it again, and I'm sure I will have to do it again. They also come with these 2 bushings. So you put 1 bushing on here, and you put 1 bushing in here, and your bolt tightens up through this whole assembly here, and you're left with a free spinning roller guide there. My next task, now that I've received these, is to make the roller guide jig or setup that holds these and allows them to adjust in various ways. So when you're thinking about roller guides, it's kind of like thinking about the 6-way adjustable seat. It has to adjust every which way under the sun. You have to be able to adjust, what would this be, the camber, the tilt, whatever, back and forth. It has to be able to tilt this way. It has to be able to move up and down, and it has to be able to move in and out and forth and back. So all those different adjustments have to be made. I will be making something here that hopefully will work for my mill. I could have ordered pieces because they have those online as well, but I didn't, because I didn't know if they would fit in my situation here. This is what I used for a roller guide when I first made my mill. It is a cam follower. I ordered these from surpluscenter.com, and they came pretty much like this, except for the fact that this little ring here wasn't on there, and so I had to make this on the lathe and heat shrunk it to fit it on here and put a couple tacks on there. That way I had something to bolt against. They actually worked fairly well, other than the fact that the diameter was a little bit too small, and they obviously don't have a shoulder anywhere here for the blade to ride against, so you have to do something different because of that. So this is what I had set up for my roller guides Actually, this was not entirely correct, but that's what it was, and well, it's a learning process. I had two rollers here, one to back the blade at the bottom, and I think, you know, looking at it now, I wouldn't obviously put this one here. Really don't need that one if the blade is tensioned properly. Now, my blade was really not quite tensioned properly, and so this probably did help me somewhat. The blade obviously rides in here, and this one would keep the blade from, you know, tilting one way or the other, or theoretically keep it from tilting one way or the other. Since it didn't have a shoulder, I had to use this guide here as a backer so the blade would ride up against this here, and it would, you know, prevent it from walking back and forth and so on. Anyway, these here are, well, these are going to be saved, but, you know, they're not going to be used on the mill anymore because they're just not quite the right thing. The real important difference between these two is going to be the diameter. Now, my smaller ones, as you can imagine, even with a moderate blade speed, these turned at a tremendously high RPM. These are going to turn still at a very high RPM, but it's going to be reduced a little bit, and I didn't really like the idea of the whine that I heard from these here. I think it was just excessive. They weren't made to be going at speeds like a dentist drill. So I thought I would make a little chart here and just show you the relationship between blade speed, roller guide size, and RPMs. This is RPMs down here. So as you can see, with a blade speed, and I put this in terms of miles per hour and feet per minute, 40 is probably slower than most people would run. 70 is probably higher than most people would run. So for the most part, I would say that blade speeds are going to be somewhere between 50 to 60 to 65 miles per hour in there. Some of the smaller mills might run a little bit slower. Some of the real big mills, they might try to push them up to 70 miles per hour. And of course, here's the same thing, just in feet per minute. Sorry, I didn't convert it to metric. Someone else can do that. So you can see the 1.5" roller guide, even at a very slow speed. This is going almost 9,000 RPMs, where I was running at about 50 miles per hour, 4,400 feet per minute. These were traveling at just over 11,000 RPMs, probably 11 to 12,000 RPMs. With my 2-inch roller guides, I'm going to target somewhere around 60 miles per hour, which is obviously 5,280 feet per minute, and the roller guides will be going about 10,000 RPMs or so in there. So these things travel very fast, and obviously if you put a 3-inch roller guide on here, you would be going only at 6,723 RPMs at that 60 miles an hour blade speed. So it's kind of important to note how big the diameter of the roller guides are, because you can potentially be going extremely fast if you run your blade speeds fast. I mean, look at here. If you actually went up to 70 miles per hour on your blade speed, which would be a fast blade speed, you would be running over 15,000 RPMs on the roller guide if you just have a small roller guide on there. All right, everyone, I think that's going to be a wrap for today. So glad I was able to share a little bit of time with you again. So appreciative of all my YouTube friends, and just enjoy being able to share some things with people of like passion, I guess, as far as sawmilling and different things go. Hopefully this just gave you a little bit of insight into what these roller guides look like. And you know, it's hard because you don't always see a good close-up of what it is that's online and what you're buying. And so I find videos like this, even though they're simplistic, they can be helpful. I know some of you are making, building, redoing your own sawmills, and hopefully this helps you out by some small measure. Anyhow, thanks again for watching, and we will see you very soon on the next video. Hopefully a video very soon that has these mounted up on the sawmill, or maybe making the mounts. Talk to you soon.